Hey everyone, Mr. Fransky here. Today we're going to talk about the last part in this little mini unit, which is the law of cosines. We've already talked about the law of sines, so today we're talking about the law of cosines. A little bit easier, none of that ambiguous case stuff with this one. So let's start though by trying some of those law of sines problems that we've talked about before, just a little warm up. So if you want to pause the video and try these yourself, you can. Make sure you draw a picture of each triangle. I would classify them first, and then see if you can solve them using our techniques with law of sines, and then we'll come back and do them together. Alright, let's try these one at a time here. This first one we have triangle EGS. Remember, I kind of always draw the same triangle, so we got EGS. Let's put in what we know. We know that side E has a length of 6, side G has a side length of 7, and we know that angle E is 60 degrees. So let's classify this. It looks like an SSA triangle, and when we have that, we have to make sure we distinguish which side is bigger. So it looks like it's a little side, big side angle. That's one of the annoying ones, right? This is an annoying case. Okay, so what we're going to do here is we're going to try to solve it. Remember, we're going to try to solve it. If we get an error somewhere along the way, then that means that there's no possible triangle. But if we do get an answer, that means there's two triangles. So we might have to deal with two triangles here. So let's set up our law of sines here. So we'll have sine of 60 divided by 6 is equal to, I guess we got to use sine of G over 7. That says sine, make it a little bit better. Okay, so now if we cross multiply, we have 6 sine of G is equal to 7 sine 60. Now we can just divide by 6. So we have sine of angle G is equal to 7 sine 60 over 6. Let's go to our calculator to be able to figure that out. Oops, too far. Okay, so let me switch over to my calculator here. There we go. Okay, so it looks like I have to do 7 sine 60, was it? Yep, 7. So sine for this calculator is over here. On your scientific, make sure that you know where those things are. Make sure you're also in degree mode, which I am not, so I got to change my settings real quick here. I could tell that real quick because it says right up here RAD. That's not what I want. Okay, so I'm going to go into my, doc settings. Settings and status. There we go. Document settings. Change this to degrees. And I'd rather have that in float. Okay. Alright, so let's do 7 sine is over here under trig. So we'll do 7 sine of 60. And then divide by 6. Gives me 1.01. Alright, so now I'm going to do sine inverse to figure out G. So G is going to be sine inverse of 1.01, and you guys can probably already kind of see what's coming here. So if I do sine inverse, so for me, for you guys, it's going to be second sine. I'm going to do sine inverse here. If that answers, go up and grab it. And I'm going to get an undefined or an error. So this actually has no possible triangle. And that's all we write. Okay, there's no possible triangle. This is not possible to do using law of sines because we got that error situation, right? So what's going on here basically, think about this, right? 6 is smaller than 7. So 6 is going to, like, it really would in reality look more like this. Here be our 6. No matter where you swing this, it's going to come to like here. No matter where you swing this, it'll never meet up with that other side. No matter how long you make this side, no matter where you put this 6 side, it's never going to meet up with that other side. Okay? So no possible triangle for that one. Let's take a look at another one. So we got MRH this time. MRH. Okay, they tell us little r is 5. They tell us h is 9. They tell us that angle r is 21 degrees. This once again looks like a little side, big side angle triangle because we have 5, 9, and the 21 degrees if we do those in order as we go around the outside. So, try the same thing. We got sine of 21 divided by 5 is equal to sine of h over 9. So I'm just going to multiply by 9 here. So we have sine h equals 9 sine 21 over 5. Let's do that in our calculator. So we have 9 sine, over here at the trig, of 21 over 5. Gives me 0.645. I think this one's going to work better. So we got 0.645 is the sine of h. So now to get h, we're going to do sine inverse. So I'm going to do trig sine inverse. Very different than dividing by sine or something. We have to make sure you use sine inverse. So I'm going to do just grab the answer there. And that gives me 40.17. So h could be 40.17. But remember, this is our annoying case. So it's possible h is 40.17. Or what else could it be? It could also be 180 minus that, right? So I guess in that case, my triangle would look a little bit different. I always draw it the same way. Doesn't matter how you draw it, okay? So we're going to have 21 still here at R. This is still 5, this is still 9, but now h is not going to be, why does that keep happening? H is not going to be 40.17. It's going to be 180 minus 40.17, which is 139.82. So that goes right here, 139.82. Okay, so now we solve these two side triangles separately. So let's find the third angle of each one. So let's do this guy over here that we started with first. So we're going to have, let's see, 180 minus 21 minus the 40.17. Going to give me 118.82. So this last one here is 118.82. Let's do the same thing for this triangle over here. So we would have, let's see, 180 minus 21 minus the 139.82 gives me 19.17. Now we got one more side to find for each one. Let's do the original one first here. So the original triangle over here, we're going to have sine of 118.82 divided by, let's call this little m. It's going to be equal to sine of, let's do 21 over 5, because those are the original numbers we were given. Cross multiply, and then I'm going to do this in one step here. So I'm going to end up with 5 sine 118.82 divided by sine 21 is equal to m. So we got 5 sine of, what was it, the 118.82, so go up and grab that. Uh-oh, didn't use the right sign. So 5, go over to trig sine of 118.82 divided by, what was it, sine of 21. Trig sine of 21. Get enter on that. Looks like m is 12.222. Makes sense, it's the longest one because it's across from the longest angle. Alright, now over here, our biggest angle, not longest angle. Okay, so we got sine of 21 over 5 equal to sine of 19.17 divided by, in this case I didn't put m here, so m. Okay, so this time m is going to be, let's see, if we multiply by m, divide by sine 21, multiply by 5, we're going to have 5 sine 19.17 over sine 21. Oh, keep jumping ahead. Okay. Alright, so I'm going to do in my calculator here 5 sine of 19.17. There it is. And divide by sine of 21. That gives me 4.581. Small because it's across from the smallest angle. Okay, so this will only deal with the ambiguous case. There are two possible triangles that could be made with when we have little side, big side angle. Just make sure you get both of them. All right, and got one more example here. So we got HQA. And we have little h is 12, little q is 7, and angle h is 95 degrees. Okay. So let's see here. What do we have? We have a big side, little side angle. Hey, that's unique. Okay, so it's going to give us one triangle. So it's important to classify because that's going to tell us if we're going to have this one triangle or two triangle situation. So let's find angle q. So we're going to have, let's see, it'll be sine of 95 over 12. Is equal to sine of q divided by 7. Multiply by 7, and then we'll do sine inverse of that whole mess. So we're going to end up with q. Let's do that in one step, why not? So we go trig sine inverse of 7 sine 95 divided by 12. Gives me 35.528. So q, 35.528 degrees. That goes right here. Now to find the last angle, we'll just subtract from 180. So we'll do 180 minus 95 minus that answer we just got, not 950, 95, minus that answer we just got. Gives me 49.47. Okay. And so now to find the last side, I'm going to do sine of 95 over 12, the ones they gave me, equal to sine of 49.47, got to use that one, over side what are we missing, little a. So if we multiply by a, multiply by the reciprocal of the left side, we'll have a is equal to 12 sine 49.47 divided by sine of 95. Oh, goodness. Okay, so I'm going to do 12 sine of 95 divided by, nope, lies, 12 sine of the 49.47 divided by sine of 95. And that gives me 9.155. And now we have the triangle solved. That's it. Okay. So, ambiguous case law of sines, just remember, classify it. If it's big side, little side angle, it's unique. Only have one triangle. If it's little side, big side angle, try to do it. If you get an answer for the first angle, then it could be that, or it could be 180 minus the value. And if you don't get an answer, that means there's no possible triangle. Cool. All right, so now we can actually jump into this question I was asking before, is so what can we solve and what is left? So let's think about what we were able to do with law of sines. Law of sines, remember, requires having a side across from an angle, right? You have to be able to create that side across from an angle. Then you can either find an angle or a side as long as you know one other thing. So that worked well with angle, angle, side. And if you have two angles and then a side, you can find the third angle. And so then you'll be able to do opposite side angle pair, no problem, because you have one side. Angle, side angle, same deal. You can find that third angle, so no big deal. And then side, side angle is the other one that we've been dealing with that had that ambiguous case. So all of these use law of sines. The last one's annoying, right? We have to kind of think more about it, but all these are possible to do using the law of sines. So the ones that we have not seen yet are the SAS and the SSS. These guys are going to use law of cosines, which we're going to learn today. Now, people always ask me, what about angle, angle, angle? Well, what is angle, angle, angle? Think about it. If you have a triangle like this, and then you make it a little bit bigger, would you agree with me that these angles are the same and these angles are the same? These are both angle, angle, angle triangles, and obviously this is by reflexive property, the same angle, right? So both these triangles have the same angles, but they're not unique. So you have to have, the way I think about it is, if you could have the same three angles, make this triangle as big or as small as you want, but once you get one side fixed, if you have one side fixed, that's going to like lock in the triangle. So you can make the triangle as big or small as you want, but once you have one side, it's going to kind of lock it in. So what we're going to do right now is we're going to learn the law of cosines for a formula we can use for SAS and SSS triangles. We're going to need one little piece of information that we haven't explicitly talked about yet. You guys have seen this before, probably in another class, but I just want to talk about what's called the Pythagorean identity. So we look at the first quadrant of the unit circle and try to use some fancy colors here. So you may remember that if we break this down into its components, so if this is the unit circle, then the radius right here would be 1. That red line represents what? I think that's sine of theta, right? Because it's the vertical value. Okay, and then we need another color, maybe purple. So along the x-axis down here, that coordinate is cosine theta. Okay, now this is a right triangle, right? So we should be able to use Pythagorean theorem on it. So what you can do is you can say that cosine squared of theta plus sine squared of theta is always equal to 1 squared, which is just 1. This is called the Pythagorean identity. This is true anywhere on the unit circle because you can always create this triangle anywhere, and when you square, even if it's a negative value, it'll become positive. So cosine squared plus sine squared equals 1. This is something you've probably seen before. We're going to use it a lot in the second part of this chapter that we do. Pythagorean. Okay, it's not the Pythagorean theorem, it's the Pythagorean identity, it's called. Pythagorean identity only has to do with this idea of using sines and cosines. Oh my goodness, stop doing that. Okay, there we go. Okay, identity. Oh, well, I guess they want us to move on. Okay, so Pythagorean identity. Pythagorean identity is sine squared plus cosine squared equals 1. That's all there is to it. Okay, now let's move on. So let's do a law of cosines proof here. So we're going to actually be able to figure out what the law of cosines is. So I'm going to draw a triangle. It has height h. And we're going to label these. I'm going to say this is side B. I'm going to say that, make sure I get this diagram right here. I believe I'm going to say that this is C and this is A over here. So then this entire side length over here is B. This entire side length is A, and this side length is C. And I'm going to call these X and Y. So just the distance from here to here is X, and from here to here is going to be Y. So what we're going to do now is we're going to use some different SOHCAHTOA stuff that we know, and also use Pythagorean theorem, and eventually use Pythagorean identity to finish this. So one thing we know is that cosine of angle C, so if you think about this right triangle over here on the left, cosine of C, cosine is what over what? I think that's adjacent over hypotenuse. So that's going to be X over A. And more importantly, that means that X is equal to A times cosine of C. Okay, it's going to be useful in our proof. And then also the sine of C, the sine of angle C, so that'd be opposite over hypotenuse, would be H over A. And more importantly there is that H is equal to A times the sine of C. Okay? So now what I'm going to do is I'm going to use Pythagorean theorem on the right side of this right triangle here. Okay, so I'm going to have H squared plus Y squared is equal to C squared. So I have H squared plus Y squared equals C squared. This is going to kind of be the basis for our proof, for being able to derive this theorem. Now I'm going to plug in some things that I know. For one, because I know things about X and H in terms of C, Y, so I could set up an equation here, right? X plus Y is equal to B. So if X plus Y is equal to B, that means that Y is equal to B minus X. So what I'm going to do is I'm going to replace that Y with B minus X. And the H, we know that H is A sine C, but I'm actually going to do that on the next part. So I have H squared, and that's equal to C squared. So what I'm going to do now is I'm going to replace X with A cosine C. Let's use some colors here to show what I'm doing. So the X right here, I'm going to use A cosine C. And the H right here, I'm going to replace that with A sine C. So let's do that. Use green for that. Okay, so I have A sine C squared plus, this will be B minus A cosine C squared is equal to C squared. Okay, so now I'm going to expand these out a little bit. So A sine C squared, that's A sine C times A sine C. That's A squared sine squared C. Okay. Then we have plus, so if we square this out, we have to FOIL. So it's going to be B squared. Then I'm going to have minus 2AB cosine C. Because that's going to happen twice, right? I'll have the outside and the inside terms will both be the same. Then I'll have plus A squared cosine squared C is equal to little c squared. So remember when we take sine of C, these are angles, right? And this little c squared is this side length over here. So now we have a couple things with a squared in front of them. What I'm going to do is I'm going to pull that a squared out and combine the sine squared and cosine squared. So I'm going to have a squared times sine squared c plus cosine squared c plus b squared minus 2ab cosine c is equal to c squared. Oh my goodness. What's happening here? Going back. I don't know why it keeps doing that. Tell me what you want me to do. I want you to stay and stop doing that. Okay, here we go. Alright, where were we? Here we are. Okay. So now, sine squared plus cosine squared, we talked about this before, that's always 1. So this is just a squared, apparently we're red now, plus b squared minus 2ab cosine c is equal to c squared. This is what is called the law of cosines. Okay, so one thing people notice a lot at the beginning is it looks a lot like Pythagorean theorem, right? A squared plus b squared equals c squared. It just has this 2ab cosine c thing here, and that's actually true. That actually is, this is where Pythagorean theorem comes from, and just so happens that the right angle here, what is cosine of 90? Cosine of 90, that's the top of the circle, is 1. So if cosine of 90 is the x-coordinate, right? X-coordinate left and right, so it's 0. So it makes this entire thing go away. So if you have a right triangle, this turns into a squared plus b squared equals c squared. So let's get this formally written. Maybe go back to green. I feel like red's a little bit offensive. So our law of cosines, c squared equals a squared plus b squared minus 2ab cosine c. Now because the lettering of a triangle is arbitrary, doesn't really matter where you put the a, the b, or the c. You can do this with any of the letters. So you could do b squared equals, what would it be? It would be a squared plus c squared minus 2ac cosine of b. The important thing is that the outside, so the side you have on the one side by itself, it has to be the same across from the angle that you use for the cosine. Our last one could be a squared would be b squared plus c squared minus 2bc cosine of a. Okay, so once again, the important thing is that the side that you have by itself here and the angle over here have to be across from each other. Okay. So let's take a look at some examples and see how we can actually use the law of cosines. But if you write down one thing today, make sure you write down the law of cosines. C squared equals a squared minus b plus b squared minus 2ab cosine c. That's the one that pretty much everyone knows. So you got triangle PAF has P is 14, F is 7, and angle A is 85 degrees. Solve the triangle. So let's draw PAF. Classic Fransky triangle here. So side P is 14, F is 7, and A is 85 degrees. What kind of triangle? Looks like an SAS. Thank goodness, because that's what they told us it is. All right, so we got an SAS triangle. Can't use law of sines. Why not? Because we don't have an opposite angle side pair, right? I always try to use law of sines if I can, but sometimes you can't. So we're going to use law of cosines. So what we're going to do here is we have this idea. So c squared equals a squared plus b squared minus 2ab cosine c. So what I'm going to do is I'm going to look at this. I'm going to see, what do I know? Well, I know one angle. That's going to be the angle I'm going to use. So I'm solving for side A, because that's the one across from the angle that I know. So this is going to be an a squared equals, I guess, f squared plus p squared minus 2pfp cosine of angle A. Right? So I'm writing it out with letters, but generally I would just go right for the values. So a squared, A is what I don't know. So that's going to be 7 squared, which is 49. Plus 14 squared. 14 squared, let's see. I think that's, is it 298? 14 times 10 is 140. Maybe, oh, this is terrible. My goodness. Brain's not working. Too late at night. 4 times 4 is 16. Definitely not 98. What am I thinking? 10 times 4, so we have 2 40s, and then we have 100. 196. Goodness. Okay. And then minus 2 times 7 times 14 times the cosine of angle A, which is 85 degrees. Now, the nice thing about an SAS triangle, because we have this side that we're trying to solve for by itself over here, we can just plug the rest of it into our calculator. So what I'm going to do is I'm going to grab my calculator over here. I think I was thinking of 17 squared. That's going to bother me. So I go to my calculator, and I'm going to just type everything in. So I'm going to do 49. And you could even do it, like if you have a Inspire, or even on your scientific calculator, you can do this. You just do 7 squared plus 14 squared, so you don't have to think about it like I had to, minus 2 times 7 times 14 times the cosine of our angle, which is 85 degrees. I'm still in degree mode. Yes, perfect. So now I hit enter. Is that my answer? I don't think so, right? Because we haven't taken the square root yet. So we have a squared. Right now I know is 227.91. So I'm going to take the square root of that answer I just got, and that's going to give me 15.096. Okay, so A right here, 15.096. I love law of sines problems because what am I going to do now to be able to solve the rest of the triangle? Well, now I have that opposite side angle pair, so I can use law of sines. So I can do sine 85 divided by 15.096 is equal to, let's do angle F. So sine of angle F divided by 7. Multiply by 7, and then sine inverse. It's going to give me F. So let's do that in our calculator. So I'm going to go to sine inverse. Nope. Not control. Not what I want. Go away. Trig, sine inverse. I'm going to do 7 sine 85 divided by 15.096, which I should have right there. And that gives me 27.51 right here. And then I'm going to round it out just by subtracting those from 180. So I'm going to do 180 minus that answer minus 85, and that gives me 67.48. That goes right here. There we go, and that is how we do law of cosines. Okay, with SAS. All right, let's try another one. So here we have side, side, side. So we have triangle SVD. We got S is 4, V is 8, D is 11. Okay, so for this one, we just got to figure out which angle we want to solve for. I don't know, let's solve for, I guess, S first. So when you solve for S first, I need the 4 squared on the left. So we have 4 squared equal to 11 squared plus 8 squared minus 2 times 11 times 8 times the cosine of, what is it? Do we say S? Okay, so we're going to solve for S. Now, people, when they see this, do make the same mistake all the time. So 4 squared is 16, right? So what I'm going to do is, some people just, they do 11 squared is 121, 64, and they subtract this thing. I can't do that because of order of operations, right? This is like in a prison. So what I'm going to do 16, I'm going to subtract 121, subtract 64. And that's going to be equal to negative 2 times 11 times 8 times cosine of S. Okay, so let's go to our calculator. So I'm going to do 16 minus 121 minus 64. Okay, it gives me negative 169. Is equal to negative, let's see, 22, 2 times 11 times 8. Oh, no. Times 8, so there we go. So it's 176 cosine of S. Okay, so what I'm going to do now is divide by negative 176. So I'm doing negative 169 divided by negative 176 gives me 0.960. So 0.960 equals cosine of S. Then to undo that, I did cosine inverse. So I go to my trig, cosine inverse, grab that guy, and we get 16.213. This is how we go. So 16.213 is S. And now what can I do to solve it out? I can use law of sines, right? And I'm not going to do this because this video has already gotten pretty long. But I'm going to do sine of 16.213 divided by 4 is equal to the sine of, I don't know, D maybe first divided by 11. And you guys know how to do this, right? So we're going to find that angle and then we'll subtract from 180 to find V. Okay. All right. I think I have one more example, and this one's kind of cool. So we will do this one all the way out. So we have a regular decagon. I'm going to try to draw that, but I think it's going to go miserably. Let's see what happens here. So 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Look at that. It's an ideal decagon. Wonderful. Has a corner-to-corner measure from here to here of 8. Okay? What is the area? So when you first look at this, you might kind of think, I have no idea how to do this. But it's not too bad. What we're going to do is we're going to divide it into triangles. How many triangles would there be? If I had drawn it correctly, there should be 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. The whole way across is 8, so what's halfway across? Well, I think it'd be 4. All right, so we got 4 halfway across. So what I'm going to do is take one of these triangles out. So we have a side length here of 4 and a side length here of 4. So we have 2 sides. How about an angle? Well, if there are 10 identical triangles, how big is this angle right here? Well, 360 degrees in an entire circle, divided by 10, 36 degrees. What kind of a triangle do I have now? I have a side angle side. Right? We have a side angle side triangle here. So if we have side angle side, SAS, right? We can use law of cosines to be able to find the other sides, but I don't think we actually have to do that. I'm trying to think why this is even in a law of cosines thing. I guess you can solve this using cosines, but what I would do, remember our formula we learned for area of a triangle? 1/2 times AB times cosine of the angle in between them. We can just do that, or sine, excuse me. We can just do that on this one. Right? I think it's just because it's a side angle, side triangle. I'm not really sure why I had that here. But anyway, so what I'm going to do here is going to do 1/2 times 4 times 4 times the sine of 36. Okay, so 4 times 4 is 16, divided by 2 is 8 sine 36. So the area of this triangle, using our little tricky formula there, so we have 8 sine of 36, gives me 4.7. And then that's one of the triangles, so to find the area of the entire thing, I just multiply by 10. So it looks like it's going to be about 47. Still trying to figure out why I had that on the law of cosines, but it's a side angle side triangle, that might be why. Okay, even though we didn't have to solve for any additional values, Not too bad. All right. That's all I've got for you guys. I love you guys. That's why I'm here. Have a great day.